Now you will learn about subnets in more detail. We mentioned earlier that you can create subnets to further segment the VPC address range and provide logical groupings for resources. For example, you could create a separate subnet for resources of different types, such as EC2 instances and database instances. You could also create a subnet for resources with different levels of visibility, such as public or private. You can also use subnets to divide resources by team or department. You can create up to 200 subnets per VPC. For IPv4, the minimum size of a subnet is a /28, or 16 IP addresses. For IPv6, the subnet size is fixed to be a /64, and only one IPv6 CIDR block can be allocated to a subnet. For more information about subnets, search for VPC Subnet Basics in the AWS online documentation. This diagram illustrates the following characteristics of subnets. First, subnets can only exist in one and only one availability zone. Next, the address range of a subnet CIDR block must be a subset of the address range for the VPC. Subnet CIDR blocks in a VPC must not overlap. This is true in the diagram for the two subnets, which are comparing the third octet. Finally, traffic to and from each subnet flows through the implicit router of the VPC. After you create a subnet, you can specify whether you want to automatically assign a public IP address to new EC2 instances that are located into the subnet. This is useful for a public subnet that is intended to host EC2 instances that are accessible to internet clients. Before an instance can be publicly accessed, it must be assigned a public IP address. By enabling this subnet feature, you can automate the assignment of an IPv4 or IPv6 address to EC2 instances that are launched into the subnet. To enable this setting in the VPC console, go to the Modify Auto Assign IP Settings configuration page for the subnet. Then select the Enable Auto Assign Public IPv4/IPv6 address checkbox. Note that the assigned IP address is not an elastic IP address. The assigned IP address will be released from the instance when the instance is stopped or terminated, unlike an elastic IP address, which is a static IPv4 address that is reachable from the internet. Each VPC comes with an implicit router that directs traffic between the resources in each subnet. It also directs traffic out of the subnet. The router uses a route table to determine valid IP destinations out of a subnet. It also uses the route table to determine the corresponding target that is used to reach the destination. A route table is a mechanism that routes traffic that originates from an associated subnet in a VPC. Contains a set of rules, which are also called routes, that determine where traffic is sent. A route table contains a destination and a target. The router reads the route like this. Any traffic that goes to a destination should be routed via the target. A target could be a specific instance ID, a network interface ID, an internet gateway, or a virtual private gateway. When you create a VPC, a default route table is also created. The default route table has a rule that routes local traffic anywhere in the IP address range of the VPC. You can add more routes to the default route table. When you create a subnet, it is automatically associated with the default route table of the VPC. If you do not want to use this route table, you can create a custom route table and associate it with the subnet instead. Each VPC might also have an internet gateway attached to it. An internet gateway is a service that routes traffic to the internet. When an internet gateway is attached to a VPC, route tables that belong to public subnets might use it to forward traffic out to the internet. In the diagram, subnet 2 is associated with the default route table. The single route that is defined in the table states that traffic is allowed out of the subnet only to the IP addresses that are in the VPC address range, which in this case is 10.0 .0.0/16. This traffic is routed via a local path. Subnet 1 is associated with a custom route table that has two routes. The first route is the same as in the default route table, which means that local traffic is allowed out of the subnet to the IP addresses in the VPC address range. In addition, the second route, or all zeros/0, states that traffic to any other IP addresses are also allowed. This route also states that this traffic should be routed through the Internet Gateway that is identified by IG with an ID number. As we mentioned before, an elastic network interface is also called a network interface. The Elastic Network Interface is a virtual network interface, or NIC, that is attached to an EC2 instance. It provides the connection point that allows an instance to communicate with a network. Each network interface has one primary IP address plus additional secondary IP addresses. It also has its own media access control, or MAC address, and its own security groups. Every instance in a VPC has a default network interface that is called the primary network interface. This interface is assigned a private IPv4 address from the IPv4 address range of the VPC. You cannot detach a primary network interface from an instance. You can create and detach additional network interfaces to an instance. The number of network interfaces you can attach varies by instance type. An additional network interface can be attached to an instance, detached from that instance, and then attached to another instance. The network interface's attributes follow it when it is attached or detached from instances. When you move a network interface from one instance to another instance, network traffic is redirected to the new instance. Two reasons you might need multiple network interfaces are listed here. First, some network and security appliances prefer to be configured with multiple network interfaces. Examples of these appliances include load balancers, network address translation or NAT servers, and proxy servers. You can create and attach secondary network interfaces to instances in a VPC that run these types of applications. You can also configure the additional interfaces with their own public and private IP addresses and their own security groups. Second, if you are connecting an instance to a service that is powered by AWS Private Link, you must create an interface endpoint for it that also creates a network interface. You must then attach the network interface to the invoking instance. We will examine this connectivity option in more details later in this video. When you create an AWS account, AWS automatically creates a default VPC for you with a CIDR block of 172.31.0.0/16. This provides up to 65,536 private IPv4 addresses between 172.31.0.0 and 172.31.255.255. This default VPC enables you to start using VPC features immediately. AWS also automatically creates an Internet Gateway, a default route table, and a public subnet in the default VPC. The Internet Gateway allows communications with the Internet. The default route table includes rules to send traffic to IP addresses in the VPC address range to a local route. It sends traffic to any other IP address to the Internet Gateway. The public subnets are set for each availability zone associated with the VPC. The public subnets have a /20 size, which provides up to 4,096 addresses. These subnets have the auto-assign public IP option enabled. This option means that any instance launched in the default VPC automatically gets a public IP address. They are public subnets because they are associated with the default route table, which has a rule that allows traffic through an Internet Gateway. A domain name system, or DNS server, is used to host and resolve a DNS hostname such as www.example.com. to its corresponding IP address, such as 192.0.2.1. When you create a VPC, AWS automatically assigns an Amazon-provided DNS server to it for use in resolving hostnames in the VPC. This DNS server is called Amazon Route 53 Resolver. By default, Resolver directly answers DNS queries for domain names in the VPC. It also performs recursive lookups against public name servers for all other domain names. If you don't want to use Amazon Route 53 Resolver, you must use other options. First, you can use your own DNS server. This option requires specifying a special set of Dynamic Host Configuration Protocol, or DHCP, options for the VPC. You can also use an Amazon Route 53 private hosted zone. A hosted zone is a container that holds information about how Amazon Route 53 routes traffic for the domains in a VPC. A public hosted zone allows Amazon Route 53 to route internet traffic to resources inside a VPC. For example, a public hosted zone could allow a customer to view a company website that runs on an EC2 instance. In contrast, a private hosted zone is used by Amazon Route 53 to route traffic in one or more VPCs without exposing resources to the internet. One common use case for creating a private hosted zone DNS is called Split Horizon DNS. A Split Horizon DNS pairs a private hosted zone DNS with a public hosted zone DNS. With this implementation, a given DNS hostname resolves differently, depending on whether the lookup comes from inside or outside the VPC. If a lookup is initiated from within the VPC, the DNS hostname resolves to a specified IP address. However, if the lookup originates from outside the VPC, the same DNS hostname resolves to a different IP address. An example scenario for using a split horizon DNS is when you want to maintain internal and external versions of the same website. Split horizon DNS allows you to access the internal version of the website by using the same domain name that is used for the public website. For more information about the VPC, DNS, and Route 53 private hosted zones, search for VPC DNS or Hosted Zones Private in the Amazon Online documentation. Thanks for watching. We'll see you in the next video.